Hello, my name is Omar Fata. I'm the Chief Business Development Officer of Biovitae. We are an Italian company developing technologies for infection prevention and control. Today we're going to speak about the concept of continuous disinfection and where the pitfalls are today in traditional disinfection and cleaning. So, of course, I'm sure everyone is aware of the issue of antimicrobial resistance and hospital-acquired infections. It's probably the biggest problem of our generation. We've benefited a lot from the invention of penicillin, but obviously the overuse of antimicrobials has led to the development of multi-resistant pathogens, and in the context of hospitals or healthcare spaces, you have obviously superbugs, which then cause hospital-acquired infections. There are many, obviously, angles to this problem, but in the context of disinfection and reducing the level of these superbugs in the environment, this is the focus of the conversation today, and I think is a very overlooked area of the problem. So when we speak about traditional disinfection, you can use, say, chemicals or UVC, for example, but obviously those require that you vacate a room, for example, that you empty the room, you have cleaning of some sort, chemical disinfection, or you switch on a UV light, and you have a reduction of the microbial amount, but then obviously as soon as that is finished and people start to enter the room again, then you have an exponential growth of these pathogens. And in this case also they can develop resistance as well. So what do we mean by continuous disinfection? Primarily what we're trying to talk about is that we're trying to address the issue of recontamination. Okay, is something that you can have without interruption, that is completely passive, and obviously it needs to be completely safe as well for your exposure, for humans, animals, and also compatible as well with all the materials that you find in the space you're trying to disinfect. It's very important to mention as well that, you know, when we speak about manual anything, when we speak about specific manual disinfection, the performance of it is very much linked to the training of the person that's actually cleaning this space, and this is where you have a lot of manual errors that enter and can cause. Because in the end, you're trying to fight something you cannot see, so is very difficult to control in that sense. So where do we need the continuous disinfection? In our perspective, we see that you need it everywhere in the hospital, because pathogens move around inside hospitals. And actually, they did a very interesting study. I can't remember the name exactly right now, but they basically used a plant virus, so not harmful to humans, and they put it next to the bed of a patient, and they followed where that virus traveled around the hospital, and they found it everywhere. They found it even in the parking lot outside on the cars. So it traveled all across the hospital, and the vector was actually on the coffee machine, where everyone was all the nurses were pressing the same button, and they were spreading this plant virus all around the hospital. So this is why it's obviously, you have critical areas which are very important to disinfect and make sure that you have a very good hygiene level. But you have to consider again that humans are kind of the targets and the vectors for these pathogens. So we've developed a light. Like, this is just one example of the light. It looks and works exactly like a normal light, and you are able to continuously disinfect environments without the use of any dangerous UV light. So this is a very important point, because we use a combination of frequencies in the visible light spectrum, and we're going to go into that detail to show you exactly how that works. But essentially, we use visible light in order to control microbes in the environment. And this is not just limited to this light bulb, but actually you can have all kinds of shapes of lighting, since the technology itself is on the LED level, the light diode level. So these are all traditional lighting formats that you would expect in 90% of places. So. Okay, so we basically, this is our spectrum. So as you see here, we have no frequencies in the ultraviolet or infrared. It's all in the visible light area. And the inspiration from this actually came from the sunlight. So of course, you know, people treat the sun like it's a light bulb, okay? But obviously, light is just one part of what the sun does. The sun is actually the bioregulator of Earth and of life, and every band of the spectrum has a function in nature. If we speak about this, so if you consider that you spend more than 90% of your life indoors, okay, you work indoors, you sleep indoors. I hope you play indoors, you do everything indoors, and so we are completely disconnected from these frequencies that actually safely kill pathogens. And that's why, and also when you speak about hospitals and you speak about indoor spaces, that's why bacteria are able to develop resistance, because they're not being attacked by these frequencies. And of course, they're also exposed to antimicrobials and biocides continuously. So they develop very, very strong resistance. So we use basically a combination of frequencies between 400 and 420 nanometers, which are highly germicidal. And this is not like our discovery. Like this was actually discovered by the University of Strathclyde in 2008, 2009, and they discovered that single wavelengths of blue light are able to kill certain pathogens in nature. But if we speak about the spectroscopy of microorganisms, obviously every kind of pathogen absorbs light and is activated in a certain way by light. And they have different shapes. As you can see here, you have just 6 examples, but you can see that they have different peaks of absorption. But you can see that they're all in kind of the 400 range. And if we take the example of E. coli, for example, okay, it has a peak at 426 nanometers, and the absorption spectra looks exactly like this. So here, it is now in orange. That's the orange one is E. coli. The blue is Biovitae, is our spectrum, and the gray is the absorbed spectrum. So if you take those two spectrums, you can actually measure how much of our spectrum was absorbed by that pathogen. If you compare that to using a single wavelength of blue light, for example, if you take just this example of 405 nanometer, you can see that the absorption is much less. Okay, and we speak about, in this case, we speak about 74% less. We absorb, the bacteria is able to absorb our frequency 70% more than a single wavelength. Therefore, it actually works much with much less energy, and you can also combine that blue light with white light. Okay, and essentially what happens after the bacteria absorbs, so the bacteria absorbs them through the porphyrins or the flavins, and after that is absorbed, what happens is that you have a chain of ROS, so you have reactive oxygen species, you have H2O2 generated, and the bacteria in this case totally dies. And in the case of the action on viruses is different, but we speak about bacteria for the purpose of this discussion. For biofilms as well, it's highly effective because our lights and visible light in general is able to penetrate transparent membranes, and they are able to actually kill the superbugs directly inside the biofilms. So it's a really innovative way of controlling them. And of course, if you think about ultraviolet light, okay, ultraviolet light works by targeting the DNA of microorganisms or the RNA. Of course, it cannot differentiate between my DNA, your DNA, plant, good bacteria, bad bacteria. It kills everything. But so does the nuclear bomb, So it's not really selective. Whereas in this case, these frequencies are target specifically the porphyrins and the flavins, so they are very, very selective. So safety, of course, one of the main value propositions we're talking about is that you can use this light safely in the presence of humans. And we actually all of lighting devices are regulated by the standard IEC 62471, and this puts different lighting products in different photobiological risk groups. Okay, so we tested all of our products, and we are in risk group 0-1, which means that you can use them without limitation. There is no occupational hazard. You can use. There's no training to use them or install them, and that is in the same risk group as the lighting you have today, in this room. But we took it a step further. So we actually did live testing on live cells, because of course this light can be used in places where you don't, burns victims, or in an operating theater or something, where you don't have skin and you have maybe exposure directly to cells, and we had no effect on the cells. You can see here, like the first row is UVB. So on the left side is the culture, and then on the right side is after the exposure to UVB. You have a reduction of the cells. The second one is 222 nanometer, which is something called far UVC, which is completely killed all of the cells. And down here you have 400 to 420 nanometers, which are the frequencies that we use, and there was no damage on the cells at all. And this is actually this was done by one of the largest dermatological institutes in Europe. It's in Italy, and they're publishing a paper on exactly on this subject. So the second, also the first value proposition is that it works. Prove it works. Okay, we spent really years in testing, and we've done a lot of testing. We actually don't have a laboratory, so all of the testing that we've done has been independent testing by third parties, and we have tested these bacteria that you can see here, including also viruses. And we have 3 publications. The first one is actually on SARS-CoV-2, because we were the first to discover that this visible light is able to kill the coronavirus. I don't know if you guys remember, but Italy was one of the first countries to be hit by the pandemic, and we were very lucky to be able to test with the Italian military, to test Biovitae on the coronavirus. And not only did it worked very well, and they extended the test to include the German and the Swedish military laboratories, and all 3 labs then published a paper in the Journal of Photochemistry and Photobiology with the results. We have another one on meat, where we tested, because it has also applications for food, so we tested on meat. And the latest one being on Mycobacterium tuberculosis, where we had a really, really good effect. Just actually yesterday we got the news that we have another one coming out, is by the University of Birmingham, and we have Dr. Helen here from the University of Birmingham, who did a lot of testing of Biovitae, and they're publishing as well in a few days. So this is just an example of what it looks like when you have. We have, of course, different kinds of testings. We have testing in the laboratory, and we have also testing in active environments with people. But you can see here just an example of the reduction that you can expect. But not only. One interesting thing that the University of Birmingham did was they did flow cytometry analysis. So they were trying to identify whether the bacteria that we're killing are actually dead or are they injured. Okay, and they found a very good effect that there actually was no injured bacteria. They were all actually dead, which means that they have no chance of developing resistance. So this was really an interesting test that they carried out. So this is what you can expect with chemicals, UV and Biovitae. Of course, you're able to use it, again, without any limitation. So you can have it on, and also there is no compromise on the light quality or the intensity of light or even the electric consumption. So you still have the same electric consumption you would expect from a high-quality LED light. To summarize how we compared UV and chemicals and Biovitae, we used three things. So we used the risk, okay, whether it's safe or not safe. We have the sanitization, whether it's manual or continuous. And then we have the environmental impact, whether it has any byproducts or it has any negative impact on the environment or high energy consumption. And it looks biased, but actually it's how it is. I mean, chemicals and UV are not safe for exposure. They are manual, so with UVC you can expect to have some kind of manual operation to turn them on, and obviously they have a high environmental impact. Whereas with Biovitae is a continuous system, there is no risk for exposure, and it has no further impact than a high quality LED light does. So of course we are very well protected. We have over 20 patents protecting this technology all around the world, and we are developing it in many different countries. I just wanted to show you just some projects that we've already done, because this is not in an ideation stage. This is actually in the market for over 1 year now, and we've done projects in almost every sector. So these are just some healthcare applications. This is the largest dermatological institute in Europe. It's in Rome. This is a polyclinic also in Rome. We have it installed in Fiumicino Airport, in the emergency hospital they have in the airport. This is our latest project. We installed it in the largest nursing home group in Italy. It's called COS. And they did a very interesting test where they actually tested Biovitae in comparison to chemical disinfection. And they made some really interesting findings. Is that they also, not only did they discover that Biovitae worked well and it reached all the targets that they wanted to reach, but they found that chemical disinfection was actually increasing the contamination. So this is where the operator mistakes can happen, and is exactly what we're trying to avoid. We have it installed in also education, so in Dublin City University, also an elementary school in Germany. These are the teachers, not the students. Offices. We have it also in the food industry. We have in a mozzarella factory, also a meat factory in Italy. In different educational centers, high schools, and supermarkets as well. And also, it's important to note that probably about 50-60% of these projects, they've also validated the technology. So they've invited external laboratories to actually validate the technology. This is in the Lavazza store in London, in the flagship store, and we have also Sampdoria, which is a Series A football club where they've installed it during the pandemic for the athletes. We also have a lot of vertical applications, so it's not just limited to general lighting, but because this technology is very versatile, we're doing also a project to put it inside trains, inside buses, and also automobiles. The latest project, which was actually just announced a few days ago, is with Haier. I'm sure you've seen this company, and they created the first sanitized dishwasher to kill all the biofilms inside the dishwasher and also reduce the odors coming from the bacteria. So if you're in the market for a dishwasher, please support us.